Thank you for joining us. My name is Noemi Greyzdorf. I'm with Interlock Technologies, and today we would like to introduce you to the world of data migration. We have been, let me tell you just a little bit about us. So Interlock Technology was founded in about 2009, and our original focus was migrating data off of old or older protocols like CAS, if anyone remembers that. That was for archiving, into more modern protocols. We have successfully completed over 1,000 migrations at scale. Some of our migrations have been in petabytes, not just a few hundred terabytes. The solution and the approach has always been to transform the data, and I'll talk a little bit more about that, but transformation of data when you're doing cross-protocol migration, so if you're going from, let's say, a NAS protocol to an object protocol, the way that data is laid out, the way the metadata is laid out, the way the permissions are done, all of that is very different, and how applications write to those protocols is different as well. So we make sure to transform the data to accommodate the various application requirements, which is when we say that we keep application consonants that implies that type of transformation. We have a number of protocols, unstructured data protocols, and many applications, commercial applications that we support out of the box is part of our data migration service. We also have developed a data migration software, which can be utilized by any data migration engineer or professional services person to perform data migrations in their own facilities or for their own customers. So why do you care about data migration solution? This is an important question because many talk about, well, I just copy data from here to here and it's all good. So let me give you a couple of scenarios that really highlight and demonstrate, why we're here, why Interlock Technologies exist, and why data migration is a complex situation. So let's assume you have an organization with 1.5 petabytes, and it doesn't have to be in petabyte scale, it can be smaller. And they have, let's say, 3 applications. One is a commercial application, sort of off the shelf, something you can buy, whether it's email archiving application or video recording application, but it can also be a custom application developed in-house. And they had been using REST APIs or REST-based storage in order to store data for these applications. And now as they go forth and they need to upgrade their infrastructure, they really want to move everything to a standard S3 protocol. Now, REST and S3, they're both object protocols, but the way that applications interface with each one is going to be different. So one of the challenges when you're doing this type of migration is you need to accommodate how the application writes to the protocol. So one of the examples is, and one of the challenges is that no 2 applications write the same way. So how you write to an SMB share, application A versus application B may be very different in where you store the metadata, how you do permissions, where you store permissions, how you execute on retention, whether you encrypt or don't encrypt. The same thing is true for object-oriented protocols. If one application writes to REST, the second application probably does it differently. And so when you migrate the data from REST to S3, let's say, you need to accommodate those differences and transfer and transform the data, which is more of the metadata attributes type of things, into how that application would write to S3, for example. So this is what we call application awareness and maintaining application consonants. So traditionally, these scenarios, you could use the application to do the migration, copy here, write over here, or cut and paste, as you may say, but there's challenges with that, both in terms of doing it at scale, impact on infrastructure, etc. So this is one example where you really need to be considering data migration solutions. Here's another example. In this case, we are all familiar with, or hopefully some may be familiar with the idea that you have a tiered environment. So let's say I write to a NAS share, and then that NAS share may stub it out or tier it down to either an object store or another NAS for lower cost storage scenario. So your file system that you're mounting and that you see might be much bigger than what is actually stored on the NAS head, whether it's a gateway or just a front-end file system. When you try to get the data off of this, if you're trying to migrate to something else, let's say I don't want to use a NAS gateway, or maybe I just don't want to use that architecture. I want to just go to a really, really large NAS. There are a lot of challenges associated with doing this migration because you have to now rehydrate the data. If you're not careful, you can overwhelm the cache or the front end NAS, which can have production implications. So when you have these type of scenarios, you really need to have a tool that understands this and can do the migration with little to no effect on the productivity of the environment, and do it in a least disruptive, highest performance manner. Again, having a solution in place will help in this case. Another example, this is more on permission. So even if you're migrating in a typical environment, whether it's S3 to S3 or SMB to SMB, and we call this like-to-like migrations, there is additional complexity in addition to the scale at which you might be doing the migration. So making sure that you can copy the data over as quickly as possible. With fewest possible delays, but permissions can be an issue. How you do permissions on one NAS, on one SMB share, you can have local permissions. In addition, you can have then Active Directory permissions, and then migrating it to a different NAS that might have a different handling. They might have different SIDs. So these, again, are challenges that if you have a migration solution in place, you can oftentimes automate these tasks and ensure greater accuracy. So this is why we talk about migration as an area that people should think about and consider when they're moving data. So here I'm going to give you a couple of insights into our architecture of what we actually offer. So we call this any to any, anywhere, or A cubed data migration. What I mean by that is that we can migrate any data. So we talk about unstructured data, but we're talking about application data, end user data. We migrate this across any storage, including any unstructured data protocol. So we support NFS, SMB, S3, CAS, REST. We can even address some tape use cases. We migrate data both on premises, so locally. We can do it from edge to center. We can do it to the cloud, from the cloud, although I can't help you with the egress costs, unfortunately. We are fundamentally, at our core, compliant with any kind of regulatory requirements around data migration, and we ensure application consonance, so consistency of the application during the migration, especially when it comes to cross-protocol migrations. And finally, we have all the data verifications built into our solution. So we go any data, any storage, anywhere. Our DATAFORGE software is designed to both scale up and scale out, which means that once you deploy the software, it all runs in virtual infrastructure, you deploy the data movers. Each one can run up to 128 threads, and it's designed to really optimize the throughput of data from source to target. Oftentimes, we run into situations where the source system may be an older version. It might be a static environment, but it could also be an active environment where users are interfacing it with regular cadence, which means we have to really be cognizant of effects of the migration on that infrastructure. So all of this is really designed to optimize the whole process.
What does the compute footprint of a data mover look like CPU and RAM?
So it depends if it's a scale out or scale up. It can run, and Mass jump in if you want to give them some examples, but it can be as little as 8 cores or in as large as 64 cores, and the appropriate amount of memory. It's not a very large footprint, realistically, but Mas, can you give him some examples in what we
Of
have done?
course. Hi, I'm Massimo Magazzi. I'm Chief Technology Officer of Interlock Technology. Uh, for the nodes themselves, as Naomi was saying, with the scale up, we would generally want to increase the CPU and the RAM when you have a very fast responsive system. You have very fast networks, say 10 gigabytes or greater. We
Hmm.
won't need to use as many movers because we can obviously fill the line that we're migrating data from source to target. When we have older systems where we have multiple nodes, but maybe it's just 1 gigabyte for network connectivity, you're going to want to use multiple movers, but not as much CPU and memory because you're obviously not going to be getting data out of a source and sending it to a target as fast as if it was all 10 gigabit.
What is the structure of the data movers and node? Are these physical machines, or how would you implement these?
These are virtual machines. So you would create a virtual machine and you would download our software.
Okay, and is it a particular type of virtual machine, or can it run on any virtual infrastructure?
It really runs on VMware ESXi.
Okay, thank you.
And how does this work then? Were you guys compatible with like hyperscale or cloud to cloud migrations?
So we support, today we support AWS and Azure. Both have ESXi infrastructures, so you would have to deploy them in that infrastructure to facilitate the migration. We haven't had requests really to do cross cloud migrations to that extent.
Mhm.
Mostly either to the cloud from on-premises, edge or data center, or repatriation from the cloud to on-premises. So, and we only need access. We only need to run this infrastructure in one location. So, whether you're going to the cloud or from the cloud, you can run it on premises. You just need to make sure you have access to the data that is running in the cloud to either write to or from it.
Does your product become the new application endpoint during this migration, or will the application still be talking to both the original source and target?
Yes, the application will be talking to the original source until the cutover. We are not in the application data path. What we're actually doing is one of our secret sauces, just to get to it before we get into the demo, is that we migrate data at the storage layer. So oftentimes when you have an application and you try to use the application to do the migration, it's now doing the dual task of actually serving data and then copying data over. In order to use it, oftentimes you have to really build it out. So it's very intrusive and it's very costly. So what we have designed with our application aware migration is we go to the storage. So underneath the application and we copy storage to storage. So we're bypassing the application altogether. And until the cutover, the application is going to continue reading and writing to its target on the source system. Once we have completed the full migration and perform the cutover, then the application will automatically be reading and writing to the target. But we're not in the data path or with the application working ever.
So just to be clear, what that means is that once we perform a migration, you could literally remove our software and your application will still function. We're not any kind of a gateway. We're a data transformation company, right? So once we're done, the application will be reading directly from the target.